Right, 10D looks at circles. So we look at the circumference and area of circles. We look at annulus, I can't say it. We also look at arc lengths. So circumference and area of circles. Remember, circumference is just the perimeter, and area and circumference can be described using A equals pi r squared for area, and circumference is 2 pi r. R is your radius, so from center to the outside of the circle. And remember that the diameter is from one side of the circle through to the other. So there is, I suppose, our definitions. Example 1 is looking at the circle with a radius of 3.8 centimeters, and we're asked to find the circumference correct to 1 decimal place and the area correct to 1 decimal place. It's a straight substitution, really. So circumference is equal to 2 times pi times r, which is equal to 2 times pi times 3.8. And I'm just going to use my calculator, and I get 23.9 centimeters. Now, thing to note here is when I typed this into my calculator, I used pi. Pi is located second button from the bottom on the left of your CAS calculator, so it's a pi button. And when you click that, there's a number of different options. Just select pi. You can also type pi. That will do the same thing. What you're not allowed to use is 3.14 or 22 divided by 7. Those two options for pi are no longer reasonable. We've hit beyond that level of maths, and you do need to use either pi or pi. It stores it to I don't know how many decimal places, but enough that we actually get some accuracy, whereas 3.17 you'll get errors very quickly, very easily. So I'm going to box the 23.9, that's correct, and I move on to part B, which is the area. So area is pi r squared, which is pi times 3.8 squared, again into my calculator. So notice this is my screen with pi, so I click the pi button. There's pi, there's I, there's infinity, e, theta, and a bunch of different things. And realistically, we're probably only going to be using the pi button out of here. So select pi times 3.8 squared, and I get out this 45.36, which I'm going to round up to 1 decimal place, so it's 45.4 centimeters squared. Make sure you've got those units right in there. Red box my answer, and that question's alright. An annulus. Think of a donut, basically, or a wheel. So annulus is a flat ring, basically, bound by 2 circles. So you've got your outside circle and your inside circle. If you calculate the area of your outside minus the area of your inside, you'll have the area of the annulus, which is, I suppose, what we're asked to do. So in this scenario that we're looking at here, we've got a path which is 1 meter wide, and it's to be built around a circular lawn of radius 4.8 meters. So the circle in the middle is going to be 4.8, and then around that is going to be a 1 meter wide path, and we're then asked to find, well, what is the actual area of this path? So we can calculate the area of the big circle, so this whole circle, which has a radius of 4.8 plus 1, so a radius of 5.8. So this part here is the area of the big circle, so outside of the path, pi times 5.8 squared, and then we're going to minus the small circle, so minus the lawn off this. So we go pi times 4.8 squared, and when we do this, we just put it into our calculator, and we'll get out a result. So we got out 33.3. And this needs to be to 2 decimal places, so 33.30, and our units is meters, so meters squared. Red box our answer. The last section is arc length. We're not going to make this optional. It's needed to know. You need to know how to do it. So the arc length of the circle is basically the length between the outside of 2 points. So this point here, for instance, and this point here. And we want to know what is this distance, this curved distance, around the outside. The arc length, which we're going to call S, is given by this formula here. So radius is times by the angle divided by 180 times pi. The angle is the angle between the two lines that meet from the middle out to the edge of our arc. So from here and also from here to the center. So that's our angle in here. So for example that we've got here, we're asked to find the arc length to correct 2 decimal places with an angle of 40 degrees. And then also we're told that the radius is 7 centimeters. I've drawn a diagram. This is my scenario that I'm dealing with. I am just going to substitute it straight into this formula though. So I get S is equal to well, my formula that I have, and then substituting in. So S is equal to 7 bracket 40 divided by 180 times pi. That's what I'm going to put into my calculator. I could simplify it by hand, but when I hit the pi, I really do need the calculator. So 4.88 or 89, the 6 will round the 8 up, and red box that. This is a length, arc length, so we need centimeters as our unit.